All right, problem of the month. Hour meter. Is today the 11th?
Yep.
Good. Yay. All right, most of you, I'm sure, will recognize this as some kind of an hour meter.
Is that the kind that you usually find on like a tractor or something that tells you how many hours of operation since the last overhaul?
Yep, generators, tractors, forklifts, equipment. I want one for my shower.
Hours or gallons?
Hours. You can imagine your teenage kids taking 30-minute showers, and you want to know, how many hours of hot water they've been running.
For smart homes, they actually have solenoid valves that will you can program to cut the shower off when the person takes too long.
Just shut off the hot water.
Yeah, right. You just put the valve on the hot water.
I think I got to take the dog out. Hold on.
So how can we tell how long the shower's been on? And when it was on, I guess, if people are...
You don't want to go.
Well, if you have a flow meter on the shower head, as you know, we can trigger on when there is flow or is not flow, kind of a thing.
Okay.
But that doesn't help for those people that have a valve up there that pinch it off because they're doing something they don't want spraying on, such as shaving their legs, and then pinch it back on again.
Well, are you going to count the time when there's no water flowing against their shower or not, I guess?
That would be a question.
That's a question. Okay, so a flow meter right at the head. Is that what you're thinking?
Yeah.
Okay.
What about just a sensor on the edge, like the bottom edge, just detecting the water, either present or absent?
Like a moisture sensor?
Like a moisture sensor, like a capacitive moisture sensor that just it's just literally, if the shower is not completely off, it's going to register flow, and otherwise it's not.
Okay. Do you think it would suffer from, after you turn the shower off, the sensor still thinks it's on for a while till it dries out?
If it's like my shower, that lasts just a few seconds, depending on whether you turn the valve completely off or not.
Yeah, it kind of drained back down to the valve a little bit.
Yeah, it just drains to the valve, and you could factor that in. You could say X seconds of the trailing edge is after a transition, something like that.
All right.
Actually, because the delay is no water, you'd almost not need to, because it's got kind of a built-in delay.
You could just put a temperature sensor on the thing and look at the increase in temperature. Because if it's cold shower, then who cares?
Yeah.
I was thinking more like an inductive sensor to sense the change of inductance in the pipe, because when there's water in there, it has a different magnetic property than without water.
So they make a doodad for third world countries that don't have hot water that screws onto the shower head, and you hook it up to 220 volts AC.
Oh my gosh.
I know, it's a horror show. If you go look at it, you'll find them on eBay. And the wires aren't even insulated; they're bare. But because the droplets don't form a continuous stream, nobody gets hurt. But they have believe it or not, they have a safety feature that they sense the water flowing, and they turn on a switch which connects the AC to the wire. So you could either use one of those and monitor the power, which is a nightmare, or you could just figure out a way to monitor the electrical condition of the wires that are now immersed in water, the resistance or something like that.
Yeah, I used that when I lived in Brazil in the early 1990s. And they're not a third world country, so even first world or second world countries, whatever you want to call it, use them.
The ones I've seen have like Romex coming out of a hole in the drywall over the shower, and then they go into the shower head. It looks horrifying.
Yeah, I mean, it looked horrified to me too when I first saw it, and mine were on 220.
Yeah. Did they do that good of a job? It didn't seem like they do that good of a job.
It was a little better than just Romex coming out of the wall.
Well, I mean, the heating up the water, was the water?
Oh yeah, it worked great.
Really? Oh.
And I never got electrocuted.
In the UK, it's absolutely bog standard to have on-demand hot water, and the ones in the let's say middle upper echelon of bathrooms are astonishing. You push the button, the water comes out, it's at exactly the right temperature instantaneously. It's like, it makes me want to take an axe to my shower every time I come home. It's so advanced.
How did they do that?
It's just like you described, only entirely encapsulated, safe as hell.
In the wall?
In the wall, or in a little box.
They do it with electricity or gas?
Electricity.
How about a pressure sensor right in front of the head instead of a fancy flow meter?
Hey, Paul, I just put a little something on my screen if you wanted to present it.
So the pressure sensor sounds good too. What about do pressure sensors get messed up by moisture though? Would there be crud, like bacteria and gunge and?
There are pressure sensors that work fine underwater.
Yeah, I have one of those, Scott. I forget which. I think it was when we were talking about how to tell if your toilet is running.
Right.
Some number of years ago, and I ordered one of these, but I've never used it. It's still in the bag, but it's just like this.
But it doesn't run on 220. There's your problem.
You would think the spinning would help. You could tie into it to help generate your electricity at the time.
So when I lived in Ohio, I had a furnace that was totally removed from the power grid. It was gravity feed. It had ducts that were 3 or 4 feet around for the cold air return, and the hot air ducts were at least a foot around, and they went up to the registers and the floors in the upper story. But the thermostat was a millivolt thermostat, and the gas going to the pilot light in the gas furnace would generate enough electricity to run the millivolt thermostat and have it open the valve that turned the burners on. And so power goes off, the furnace doesn't even know about it.
Swimming pool heater does the exact same thing. It's not on a power grid, but it does have a flow sensor so that it's like an interlock. So if there's no flow, meaning if the main pump isn't pumping water around the circulating pump, it won't light the burner, or it'll put the burner off.
And that's not hooked up to 110 or anything?
The filter pump is, but the heater is parasitic to the whole thing.
Okay.
Be easily bypassed, but the heater itself doesn't require any power whatsoever.
Yep, that's kind of neat. Okay. Other ideas?
If I
Yeah,
were
I
one
just
of your,
saw something on Stack Exchange where they were using piezo ceramic transducers and an ultrasonic waveform. Well, the frequency of an ultrasonic waveform to bounce the waves through it to see if there's water flowing through it or disrupting it.
Through a pipe?
Yeah.
Yep.
Yeah, it's that link that I just posted from Stack Exchange, the second point in the discussion.
Okay.
if I were one of your kids, I would place a neodymium magnet right next to the sensor and saturate it.
And then your water gets cold.
No, the flow sensor. I just,
Oh, so that
saturate the flow
I think
sensor.
it's not flowing? Yep.
But then they get points for being ingenious.
That's right. At some point, I noticed that my record of when the showers were taken aren't accurate.
Well, if there's ever a contest for long showers,
yeah,
let me know. I want to hear about that because I will enter my daughter and beware. All competitors should beware. I swear she goes to sleep in there.
I think everybody's daughter does this. Mine does too.
Yeah.
I don't think it's just daughters, but I believe daughters definitely, if you have to count all the time that they've locked the door and closed off the bathroom from anyone else being able to use it.
Any other ideas?
I like that ultrasonic idea. I wonder if that'll actually supposed to work through the wall of the pipe.
That's what the diagram was. If you look down that discussion a bit, the guy's got a full diagram of it there.
Oh yeah.
I'm sure there are frequencies that would go through.
Shows reflectors though inside the pipe. That doesn't make any sense.
Yeah, I would probably do it on opposite sides of the pipe and let it flow through it or sense through it.
Yeah, I'd have to read this and figure out what they're actually trying to achieve.
I think they're using just a differential sense.
Yeah, you transmit from one, receive to the other, and then receive from one, transmit to the other, and compare the two. And if water is flowing, it's like the wind gauge, the anemometers that are ultrasonic. You have, you if the medium that you're propagating the thing through is flowing, then the time is different depending on whether you go forward or backward through the path. I don't know what the RTD at the top is, though. Two transducers in combination with an AFE. That's the chip.
RTD is one of the temperature sensor families, isn't it?
Thermocouple?
I think it's a cousin of a thermocouple.
All right.
If you run into what's called a mass flow controller, basically it's a heating element with a thermometer, and as the water flows over it, the gas in that case flows over it, it cools it down.
Right.
So you'd have to know the temperature of you'd need two temperature sensors, one of the water flowing, and then one applies one on a heating coil, and you can see how much that heating coil, you run it in a feedback loop, and you maintain a certain amount of heat into the fluid.
Yeah, that one from Circuit Digest magazine is also a flow meter.
Okay. Microphone. Could you do it with a microphone to hear whether the shower was making noise or not?
Like I said, it'd be differential, so you'd get a basis of status time and then whether there's any change.
How about vibration on the pipes?
With an accelerometer? It's possible. I think
You're
temperature.
not gonna get very
I think
much.
temperature is probably.
I don't know if the accelerometer is going to detect that small amount of vibration, but I don't know. Maybe.
Yeah, it will. But that same amount, but that sensitivity will also be false triggered every time somebody closes the door in the house.
Yeah, or walks into the bathroom or flushes the toilet, or. But you might be able to filter that out. All right, any other ideas? Camera.
Oh,
that might not go over well.
No, I don't think that'll go over too well.
Well, it will reduce the amount of time spent in the shower.
That's for sure. To zero.
The end result that you want anyway.
Yeah, they'll be taking showers at their friends' houses.
Exactly. It reduces your bill.
now Honeywell's approach is to detect the water at the bottom of the shower pan.
Okay.
That's the next link I just put on there.
You mean the drain?
Yeah.
Now that's an interesting idea.
Hey, just put a conductive mat in the bottom.
Hey, another use for 220.
Yeah.
Yeah, but I'll be honest with you. I think that'll give you false readings because after you're done with the shower, that thing's still going to be wet. And how long is it going to be wet for afterwards? Hours?
Potentially, yep.
So, you say, "Hun, you were in the shower for 4 hours." No, I wasn't. It was only a half an hour.
All right. Any other ideas?
Yeah, the water presence sensor is what Bob Viola's posting here.
Yep. Yeah, I've seen some that are like just wire that you run like in around behind a dishwasher and then through the cabinet under the sink, and it just sits there for years till it gets wet.
There's
and then your
humidity.
alarm goes off.
There's humidity. You could sense that.
That's true.
Yeah, that's a good idea, maybe. Again, there's going to be some residual effect, but
Right.
that latency.
Yeah,
And
you may be able to tune that out though.
As
Yep,
soon as the
and it-
shower door, as soon as the shower door is open, that's going to drastically change it.
Well, so it depends on whether or not you literally have doors or you got a curtain. But, you know, it could be adjustable.
what about, so we had a mat that detected water. What about a mat that detects weight? So it measures the time that you're standing in the shower.
Yeah, but then you also want to know if you want to count the time water's off, but there's somebody in there. It'd be nice if you could get a reading for both. And you can
And then the other
actually
thing
say,
would be the concern there is when you're cleaning the shower.
well, you can ignore that. How many daughters are going to clean the shower?
I was referring more to protecting the mat from the chemicals, but okay.
Oh,
I think a temperature sensor on the pipe is probably the simplest one.
I like the idea of a sound or vibration sensor on it as well.
you mean ultrasonic of some sort?
Not even that per se, just a difference in stasis level versus something going on in it.
Oh, just vibration of the pipe. Yeah. That was the thing
I know mine
before.
makes enough noise even in audio frequencies that it should be able to be detected.
Yep.
Yeah.
Because you can put the microphone right up, tape it right up onto the pipe.
Yep. You may. I know that I can hear when my drip irrigation water valve turns on at other locations in the house where there are water pipes. So you may have to do some tuning there to.
What do you do? Get a clunk on the pipes when the thing turns on?
I hear a little clunk and then
Yeah, if you're getting clunking on the pipe, you might want to figure out you've probably got an air blockage.
Well, it is an exterior irrigation system, so there's probably going to be air infiltration here and there.
I have one of those air tanks on the hot water heater side. Nowadays, the water coming into your house has backflow valves so that the water doesn't go back out to the city. And as the hot water heats up, it pressurizes the system. And so they have air bladders that compensate for the expanded volume of the water. I had to replace one of those this past fall. Okay. Anything else? Are we ready to move on? Okay. We're supposed to have a presentation tonight from Pete.
Yep.
About vector network
analyzers.
VNAs.
Okay, can you see the slide?
Yes, sir.
You see the second slide?
Yes, sir.
It actually works.
Are you on your phone, or did you get a different internet service?
I've gone through 3 different pieces of hardware to find something that actually works. So, and Kevin and Nick have both helped me out. So, in theory, things are going to work. Okay, so you can omit that part, Carl. So this is about a particular vector network analyzer, and to a smaller degree, the general case. And it's a little bit of background about me, and it dawned on me that I should leave this on the screen long enough for someone to actually read it, since this might get seen in other places. But the quick summary is I worked for a series of OEMs, and then picked the most interesting work I did to go back and make a little LLC. So I'm going to talk about a very small vector network analyzer called Nano VNA, and this is a picture of it in my left hand. I think that's my left. And as you can see, it's quite small. It has a 2.8 inch resistive TFT display, and it's quite compact. So what is a vector network analyzer? Well, it's a gadget that at the heart of it, it measures the amplitude and phase of voltages in a network. And by vector, we mean the combination of the amplitude of a voltage and its phase angle, which we'll explain in a second. And obviously a network is a connection of signal paths, sources, and sinks. And the analyzer part is just some way of displaying measurements and controlling the device. What's a vector? So with DC current, voltage is a very straightforward situation. With AC, the voltage is constantly changing in amplitude, and the polarity is reversing some number of times per second. And so it's more complicated to point to an AC signal and talk about voltage, and especially if you are trying to relate to two alternating current signals. And so the basic way to express voltage in this context is with two numbers, the first being the potential difference, the voltage, and the second being the phase angle, which is a relationship between between a signal and a reference signal. So with DC, the reference is ground, and with AC, it's some other waveform. So here's an example. So in the first curve, the excursion, the distance it's going positive and negative is relatively small, and so the length of the arrow is relatively small, and in the second one it's longer, the third one is the longest, and so there's a relationship between the amplitude and the length of the vector. And in the second slide here, we have two signals called A and B, and in the first example they're coincident, so there is no difference between the two signals, and so by definition we only have a simple vector, almost as if it was like a DC voltage being measured, except that it's constantly changing. And there's no phase shift, so there's nothing. And in the second example, signal A begins to go positive faster than B, and so it leads B by some fraction of the waveform, which is just chopped up into degrees. So we say that in this particular case, A is leading B by 90 degrees, and so the vector points up. The vector for A points up, and in relation to B. And in the second example, the opposite is true, and so in describing A, we say that the vector is negative 90 degrees. And finally, in the degenerate case, both signals are going in opposite directions at any one moment. And so the phase shift is 180 degrees, representing the two signals that are mirror images. So for the simple case, the vector is simply the phase shift between the two signals expressed as an angle in degrees. It can also be expressed in radians and expressed in yet a different way involving imaginary numbers that we're not going to go to. But in every case, the VNA is measuring the comparison of the voltage, magnitude, and phase of the two signals to plot its curves, or some mathematical derivation of the data. So what can a VNA measure? One thing that it can measure is what's called reflection loss, which is where you send a signal down a transmission line, like a coaxial cable, and you have some load on the other end, and you measure how much energy comes back in the other direction, measured strictly as voltage and phase in relationship to the signal that's going out. And you can calculate how much signal is being lost by reflection. So with AC, there's something called impedance, which is kind of the AC version of resistance. And if the impedance of the transmission line, for example, coax cable, matches the impedance, the output impedance of the thing putting energy out, and then the load is also matched, then there's no reflection. The load accepts all of the power, and none of the power reflects back. In the real world, the match is never exactly right, so there's some loss, and also there's loss due to capacitance creating loss via heat through the transmission line. Anyway, the VNA gives you some idea of measuring what that value is, and it allows you to say to yourself, do I want to use the cheap coax cable, or do I want to use the good coax cable? And depending on the circumstance and what kind of application you've got, that can translate into a large amount of money that you either save or wish you had spent. It can also measure the losses in transmission. So there are two basic modes that we're going to explain, that I'm going to explain in a minute, and that we will discuss as necessary. And in the case where you are measuring the passing of the AC or RF, you can measure how much is not coming out the other end compared to what went in. The VNA can also measure impedance, and we're not going to get into it tonight, but impedance is expressed as a combination of resistance and reactance, either capacitive or inductive reactance. A kind of first cousin to reflection loss is SWR, which stands for standing wave ratio, and that is a very commonly used measure in radio scenarios. Like for tuning an antenna, you want ideally you want a very low SWR, which translates to a good impedance match, so you know all of your transmitter's power is getting out towards your antenna or out of your antenna. At least it's getting as far as the SWR meter. The Nano VNA that I'm describing has some extra tricks in it that measures delay, signal delay, and can be used for some simple TDR applications. For example, broken wires in a cable, that can be mighty, mighty handy. This particular VNA spans frequencies from 1 to 1500 megahertz, and it has many other capabilities. at the end of the last slide's got some pointers to references. Let's see.
Hey Pete, the similar related thing is power factor. It's the measuring the power as opposed to the vector voltage and current, and it also relates the actual working power versus the reactive power.
Yeah, that's cool. So let's see. I was just changing slides. Yes. So even though there's a single name for this thing called Nano Vna, and it was built, I believe it was 2019 that it first sprang onto the scene. There have been literally dozens to hundreds of copies of this Nano Vna, and various makers have tweaked it. And one of the big problems that's been present with them is the labeling of the ports. And I have two VNAs that will show up in this presentation. There's an old one and a new one. The old one labels the first port channel 0 and the second port channel 1. And the new one properly calls the first port port 1 and the second port port 2. So there's going to be a mixture, and I apologize for the confusion, but we'll explain it as we go along. Here's a block diagram of the simple Nano VNA. It only operates in one of two modes. When the switch is in the S11 position as shown, the signal comes out of the signal source, and notice and recall that it actually, I haven't explained that it sweeps. So the signal sweeps from some start frequency that you specify to a stop frequency over and over and over again. And over and over and over again, it captures data points and plots them onto the display. So the display is showing moment by moment what the computed value is of the different graphs on the display as the frequency is swept from the start to the stop. Anyway, RF comes out of the signal generator, goes through a splitter so that the detector can capture that. It actually goes into a mixer, and the signal that is coming up through the rightmost vertical line also goes into a mixer, and inside the VNA there are signals that are labeled I and Q, and those are what are the kind of the essential flow of the bits of information that are used to compute what's going on. Anyway, the signal proceeds through the splitter upwards into the detector, but at the same time, the same signal, or half of the signal, I should say, an equal half of the signal goes down through a thing called a directional coupler and out port 1. And from port 1, it goes into a device, and when it's in what's called S11 mode, port 1 is being used to both generate the signal and measure. And this is the case where it's measuring the signal that is coming back, that's being reflected. The directional coupler through the line that's towards the top of the magenta box is sensitive to energy going in the backwards direction. And that information is captured and fed into the detector. In the other mode that the device can operate in, that's called S21 mode, port 2 is being measured, and the energy is the energy from the signal generator is again coming out of port 1. This time it's passing completely through the device, and the switch is in the other position, and so the signal proceeds out of the device under test and into the detector. So in the first case, in mode S11, it's all about reflection, and in the second case, it's all about transmission. So here's a simple diagram of the two modes in the top, and we spray painted out information that was relevant to a more capable VNA, and this has been simplified to reflect the Nano VNA and its capabilities, which consists of just the two modes. So again, in the top with mode S11, the incident power is entering the device under test, and some fraction of that, if there's any deviation from perfect impedance match, is reflected, and that information that's reflected is captured via the directional device and fed in and measured. And in mode S21, power, again, the incident power from the device goes into comes out of port 1, goes into the device under test, comes out of the device under test that's connected to port 2, and that is in turn measured. Okay, let's talk about some applications. This is a 900 megahertz ISM band dipole, and I find it cute that it's made out of coax cable. If you look, actually, you can't see it very well, but that is the shield of a piece of very small coax cable. This is the coax cable with the outer jacket on, and this is with the jacket stripped off. And the center conductor is connected in here to a second wire that comes out. So this makes the two halves of the dipole antenna, and then this is the coaxial cable feeding RF into the antenna. Now this is what the VNR shows, the VNA shows in a situation where 900 megahertz, where a sweep of frequencies from 1 to 1200 megahertz are being fed into that dipole. And the yellow trace is the log of the magnitude of the reflected signal. The blue trace is a measure of the SWR based on the comparison of what's reflected versus what's sent, and a computation of what the SWR corresponds to. If it's down on the bottom line, the SWR is perfect at a value of 1, and if it's above, it has a higher value. Now, there's a mechanism in the VNA called a marker, and these little triangles with numbers are markers. And you can drag and drop these you can drag them, I should say, with a stylus across the screen. And as you do that, they will show you what x-axis value you're at and exactly what the frequency is at that point. In this case, it's very close to 900 megahertz, which is the beginning of the 900 ISM band. And the interesting thing to me is how high the SWR is up here at the beginning. It's 1.87. As Kevin pointed out when he was helping me with this, that's actually not bad at all. That corresponds to probably in the upper 90% of transmitted signal versus reflected signal. But I like SWRs of 1. That's the SWR I like. And this would actually be achievable. This antenna is not the correct length. If you'll notice over here, down here, the SWR is very, very, very close to 1. And the 30 megahertz, give or take, of the total ISM band will easily fit into this little curve. So if this antenna were longer, this dip would be down here, and it would cover the space between the beginning and the ending of the ISM band, and the performance of this antenna would be noticeably better, although for some nitpicky definition of noticeable. But it is the case that many RF transmitters, many amplifier circuits will fold back their output power when the SWR goes up. So if this antenna were connected to a picky piece of equipment and the SWR up here is quite a bit higher than, well, in fact, if I could slide it up to here to where the frequency is, say, 920 or 915 megahertz, something in that neighborhood, the SWR, I should say, could easily be high enough to cause some sensitive transmitters to fold back their power. A lot of amplifiers will protect themselves by folding back their power output, because when the SWR goes high, it means it translates to large voltage excursions in the circuitry, which can exceed the ratings of components. So a modern high performance system will protect itself. And so this antenna, if it were longer, would have a much more optimum SWR match. Here's another antenna, and this is 12 feet long, and this is half of the antenna. The antenna keeps on going. This is the middle of the antenna, and it keeps on going all the way into that dark pit back there. And this is a dipole for 21 megahertz, the 15-meter amateur radio band. And it's telescoping aluminum tubing, so it's a 1/2-inch diameter here, and then 5/8 here, and 3/4, and so on. If this is used as the endpoint in mode S11 with the VNA, you notice that there are a bunch of somewhat resonant frequencies as this thing scans from, it sweeps from 1 megahertz to 30 megahertz. But this is the area of interest. The 15-meter band goes from 21 to 21.45 megahertz. And I've got this set at 21.3, which is very, very close to the middle of the SSB piece of the band that is my interest. And the marker is not set optimally. The marker is very, very jittery right here. It's very ticklish because the screen is divided into 100 points. And for whatever reason, it's a bit of a trick to get the thing to sit down in the trough of this thing. But the SWR is measured at 2.36 here, and this antenna is sitting 3 feet off the ground, and it's sitting in parallel with another 15-meter dipole antenna. So the SWR will be quite a bit better once it's up in the air and away from other metal.
Could that that resonance that you're seeing there, is that I'm just thinking now, the two antennas interfering with each other, and that's like the beat frequency between them?
No,
Okay.
I don't think so. This is simply reflecting the fact that the antenna can be close to resonant at a lot of different frequencies. So, for example,
Gotcha.
if I think about it for a second, well, let me not think about it, but let's just say that an odd number of half wavelengths are resonant, and there must be some relationship in terms of fractional fractions of half wavelengths that end up being resonant, but not, I mean, not well, they are obviously close to resonant. So that'll be something to play with someday using an antenna modeling system. In case you guys didn't know, the author of EZNEC, EZNEC, which is a computer model system for modeling antennas, he sold his business and he made the current professional level version of the program free to anybody to download. And all you just have to do is go to eznec.com and you can download a copy of it. It only runs on Windows, unfortunately, but it's a fantastic modeling program. So here's a zoom of, this is just a magnification of that one dip to try to express how narrow the area of interest to me is. This is the same setup, but the start frequency is 21 megahertz and the stop frequency is 21.45 megahertz. So this is the entire 15 meter band spread across the whole device. And this is how you would typically use a VNA in an amateur radio circumstance. You don't really care that much about what's going on outside the band, either above the band or below the band. It's not legal for you to be using those bands for transmission anyway. So you would typically set your VNA up to just capture the band of interest. Here is a demo kit that's available for use, not just for the Nano VNA, but for just about any. And it demonstrates a whole lot of common situations, and it also has the individual pieces necessary for calibrating. One of the things that you do with the VNA is you calibrate it to eliminate the effects of as much of your you want to common out as much of the circuitry as possible between you and the device under test, so that when you connect to the device under test, you're only seeing the differences represented by the device under test and not the differences of all of your test leads and so on. So in this circumstance, where you've got these little coax cables with these itty bitty connectors, you can use these these 4 connection points to calibrate the VNA in either S11 or S21 mode. And then you can connect these things up to the other parts and get very nice clean data that matches up with the behavior that you see in the diagrams. And here's an example. This thing up in the upper right corner is called a bandpass filter. And what that means is that frequencies that are below the pass band of the bandpass filter are attenuated. The frequency, the target bandpass frequency is not as attenuated, and then the frequencies that are higher than the band, the pass band, are also strongly attenuated. And here's whoops, wrong button. Here's an example of that circuit. 10.6 megahertz was as close as I could get to the center frequency. The center frequency is just a little wee Scotian here to the right, but these are log magnitudes, and so this is minus 21 decibels. Down here is minus 70. So outside of the 10.7 megahertz design frequency of the filter, signals are very strongly attenuated. And within the pass band, they're attenuated about 50 dB less than outside of the pass band. Also, it's relatively steep, so this is a pretty effective filter. Very often, the things that you want to stay away from are a relatively good distance away. It's only in extreme circumstances, like say a radio contest or something, that you would look at this filter and say, this is terrible. What you want is something that goes like that, so that the signals that are very, very close are rejected. So now I'm going to switch cameras. Cross your fingers.
How much did this contraption cost you?
The first one that I got was less than $50, and the second one was about 80 or something dollars. They range from about 60 to 150 bucks now, depending on bells and whistles. You can get them with 4-inch screens instead of 2.8-inch screens. And okay, I've got the camera set. And if I turn off my screen sharing,
The 2.8 inch, is that diagonal on the screen, or?
Yeah, yes, sir.
It is? Okay.
Yeah, that's diagonal. And I don't know how well that comes across or not. I'm looking at it.
Well, we can see it.
We can see it pretty good.
Okay, good. And the focus is pretty good. Okay,
yeah.
This is exactly that same example, only in this case, the frequency is scanning from 1 to 30 megahertz. And so the filter operation is extremely narrow right here. And you'll notice that the filter, for whatever reason, for reasons that Kevin would probably explain, the filter has additional pass bands, and that's a feature. It takes particular designs of filters to avoid some of these pass bands off on the side. But instead of having to deal with this and deal with this extremely jittery little marker here, which I can barely grab and move, let's change the start and the stop frequency. So it's a menu-driven system, and the first thing I'll do is tell it to set the stimulus start frequency to 8 megahertz, and then the stop frequency to 12 megahertz. And now we've got the same expanded display. And if I move the marker, oh, I got lucky. 10.68 megahertz. That's very, very close. So the marker is extremely close to the center frequency. And if I had additional traces set up to show different other measures that this thing is capable of doing that are relevant to the S21 mode, then they would be displayed along with this. This is the demo kit. And as you can see, these coaxial cables fit on. These are the same that you see on some of the dev boards, like the particles.
Yeah, I've seen those before.
Yeah, they're little tiny
They're
ones
common.
and very, very common. And this is relatively small but high performance coaxial cable.
The ESP32s have those, the ones that have a clip-on antenna.
Yeah, very good. Right. Okay. Now let me see if I can turn the screen share back on. And is everybody seeing the slide again?
Yep.
Yep.
Oh, goody. So here are some more references, some information sources. NanoVNA.com is where the keepers of the Nano VNA and their associates that have been modifying it and improving it and so on, where they hang out. It's a central source of information, and it's especially valuable for finding who to buy it from. You have to be very, very careful buying this gadget. If you're not careful, you will get one that looks like a Nano VNA, but it does not operate like a Nano, like it should, because it's been made with substitute parts, floor sweepings, sawdust, and who knows what else. You get what you pay for. So rather than going to Amazon and eBay and spinning a wheel of fortune, I recommend that if you're interested in getting one of these, you go to Nano VNA and you shop around, and when you find a source, you ask around. Hopefully, previous buyers from that vendor will have rated it and commented on whether or not it's the real deal. And also, there's quite an assortment, even from these what I would call vetted, where these sources that have good provenance, they sell an array of product. So we mentioned the 4-inch display versus the 2.8, but there are also ranges of capabilities in some of the different models. But I'd say the matrix is not more than about 6 or 8. There may be 6 or 8 devices from these sources. And as I said earlier, the price goes from about $60 up, approaching a couple hundred.
I just looked at R&L. The $60 one's out of stock.
That's right. If you'd like to learn a little bit more about complex numbers, those slides were ripped off from the well, actually, I'm giving them attribution here as I speak, to give them credit for the graphs at the beginning that explained the phase differences, but they go on to explain complex numbers and in a very, very straightforward way. And I think that All About Circuits is a fantastic source of information. Finally, if you go to YouTube and you type in Nano VNA, you'll get so many hits. You can put in calibrating Nano VNA. You can put in, applications, various search strings, and get as much information as you would like. It's been an extremely popular device because it's so accessible and inexpensive. So there's a ton of information out there. And that's what I've got. Any questions, comments?
So Have you actually used this in a real world situation yet?
Yeah, I use this for my amateur radio antenna designs. I make custom antennas
Okay.
from scratch, and I use the. Let me tell you about an application that I didn't mention. That's kind of on the a little bit esoteric. There's a gadget called a balun, and a balun is a device that translates balanced current flow into unbalanced current flow. And basically, it's the gadget that you need to take the energy from your transmitter through your coax cable and get it into your dipole antenna without the coaxial cable shield being part of the antenna. That 900 megahertz dipole that I showed you earlier is deficient in the fact that it has no balun. So the truth is that the coaxial, the shield of the coaxial cable feeding that dipole antenna is actually part of the antenna in real life when you're trying to use it. Well, anyway, the big problem with that happening is that the antenna can pick up crappy signals, like say the electrical noise from close to your house, and feed it into your receiver. So you're listening to your heat pump electrical noise instead of the signals that you would really like to be hearing. So to eliminate that, you use what's called a balun, and the balun very strongly attenuates energy that's trying to go on the outside of the coaxial cable shield, and it passes of course, the signal that's on the inside of the cable. Well, you can use a VNA to test the performance of the balun. You can use it to measure the decibels of attenuation of common mode current, and it's common mode current that's the bad thing that you're eliminating. And I designed. I didn't. Unfortunately, I forgot to put a picture of it into the slides. I could have thrown it in as an additional slide, but the balun that's on that 24-foot long antenna that I showed you, I designed that with the VNA at my elbow, and I tested many different combinations of toroids and small diameter coax cable versus solid wire versus beads on the outside of the coax cable versus wrapping turns around the ferrites, until I got something that gave me the attenuation that I wanted. And so the VNA was absolutely the difference between going on the net or going to the antenna book or some other source and just copying something and putting it together and hoping that it works, and having something that not only works, but it works at a known performance level. So I know that the common mode signals on the 15 meter band are attenuated by 32 decibels in relation to the differential mode signals. And that's sufficient for my purposes. I would like it to be closer to 40 decibels, but 32 is okay for where I'm at right now.
Hey Pete, one of the things I've discovered, because I use baluns to pass video signals along Cat5 wire and things like this. Most baluns are implemented via transformers, and this meter would very much help to discover the cheap transformers versus the good ones that you want to use in RF and things.
Yeah. Now, yeah. I mean, a whole nother approach to this is a transmission line transformer. And that's a good point. There are multiple ways of skinning this cat. So I should have said that my balun is what's called a choke balun. So it is a RF choke for common mode current. And by common mode, I mean current that is the same phase as the signal on the inside of the coax flowing on the outside shield of the coax.
On both phases, in other words.
It's the same signal, and what you want to do is you want to identify that and attenuate it, block it, basically. As you probably know, a choke presents a high impedance for higher, as the frequency goes up, the impedance goes up, and up to a certain point, and at which point it, when it turns into a capacitor, yada yada, and so on. But but the basic idea is that for the frequency of interest, it can suppress that. I'm not exactly sure how to measure the transformer style of balun that you mentioned.
You're looking at different frequencies and stuff, and what I find out is that most transformers get a very sloppy attenuation curve, and so you still need to run a lot of times a filter circuit to tune it.
I see.
Or a multiple stage filter circuit, actually.
I see. Yeah, well, that application is outside my league. I mean, out of my depth.
Well,
putting RF down a Cat5 cable is not something that I would want to intentionally do.
Yeah. Well, a lot of times you also use a similar type of thing when you're transmitting into a waveguide and then picking up from the waveguide on the other side.
I see. Anything else? Okay, well, I'll turn off the screen share. Oh, I will put these, oh, somebody else turned it off. I'll put the slides someplace obvious and point to the meeting archive and send out a URL.
Thank you, Pete.
Okay.
Is there any announcement from the Fpga Group? Stuff that has happened in the last 2 weeks?
We have or I now have the new rev of boards, which I'm just wrapping the software around. There were some small address changes. We have a meeting coming up. When do we have a meeting coming up?
We haven't actually set the date for that. And in a nutshell, I have been pinging Rob Mackey to find out when he can meet and let him gate the meeting. It would ordinarily be April the 25th, which is the Monday that is in between this meeting and the next regular meeting.
Okay.
But I'm getting an operation that day.
Yeah.
And can't make it. So I've pinged Rob, and the big question is whether or not Rob's computer robot team got into the World Championship. If they got into the World Championship, we might not be seeing a lot of Rob for a while. If they didn't, then with a little time to decompress, he's indicated that he wants to eagerly get involved. So as soon as I can connect with Rob, and I will be sure that happens in the next day or two, and I'll send out a message.
Okay. All right.
The other thing that's going on, the quick thing to report is the design of the next board is underway, and it is going to be just a small refinement of the current board with just some detailed changes, but I'm holding off on that. Has anybody read in the news about what's been going on in Shenzhen? Yeah, China,
The big lockdown.
the pandemic has gotten to China, and there's all kinds of interesting stuff going on over there.
Shanghai is where it's worse right now.
Yeah, I think Shanghai is in the news. It's like 20 million people in complete lockdown.
They won't even let you outside to walk your dog.
Yeah. So anyway,
The factories are shut down.
Yeah, we're expecting to make a run of about a dozen boards, but we do need to use offshore resources for that. And so we want to gauge what's going on. We're not, the good news is we're not in a terrible hurry with this. Then if we were to get into too much of a hurry, it would stop being fun and we would be violating one of our big rules. So everything is fine.
Oh, did you ever get those chips in? The ones for doing USB?
I got, Nick bought 20 of them and they did come in.
Have you been able to solder them without blowing them up?
Oh yeah.
Oh, good.
Oh, absolutely. The hazard was taking them out, was unsoldering them using hot air.
Yeah.
Yeah, soldering them is fantastic. Is a piece of cake. Either hand soldering or reflow soldering is a piece of cake. It was the unsoldering that I thought I might have ruined one. Well, it turned out to be a bug in the PC design. The USB chip was not to blame for that. It was
so you didn't blow them.
I didn't blow them. I blew the wiring of them, and when I put in a couple of
undocumented feature.
Yeah, had an undocumented feature that required a couple of documented bodge wires, and now all is good.
So now you got some other ones you can stick back on the board you stole them from.
Yeah, but they're at the bottom of the list.
Yeah, that's.
Hey, Pete, are you going to bring the VNA or VNA demonstration out to the Hamfest?
Sounds like it would be a good idea, doesn't it?
Yeah, it sure does.
Yeah, that would be something to have at the TriEmbed table.
Exactly.
Only if you're there to demo it.
Maybe we can get Nick out there or somebody.
Well, I'm going to be there.
Nick's going to be there.
And I'm if the base for my microscope has been machined by that point, I will bring at least a skeleton of my microscope. People might be interested.
Also, the FPGA stuff. I think people will be interested in that as well.
Yep. Yeah. So, I mean, it seems clear we're going to have stuff split between the TriEmbed area and my table is really going to be oriented towards selling some stuff. I need to. I bought the remaining stock of the Chapel Hill Radio Shack store for some of their parts, and it's how many years since they went out of business, and I'm still selling those. Yeah, I'm still selling those things, and oddly enough, it's exactly the same display that we see. The only difference is that it's designed to plug into an Arduino, and I would be very surprised if they're using that particular design inside this VNA.
Yeah.
Anyhow.
All right. Show and tell. I have something.
I just have a comment on the project that I was working on for the TFT LCDs, but nothing to really show yet.
All right, well, make your comment.
Well, I got it working on a Raspberry Pi at this point. I'm writing the tests for the API to make sure it actually, all the features work, but the basic functionality is there. Something I have noticed, and anybody else that does this, even if they're using C code, almost everybody that writes this code, it actually only works properly on a BGR colors, not RGB. However, they almost always supply you RGB colors, which means all the colors are weird. Blue is red and red is blue. It's nuts. And I can't figure out why nobody has caught this yet. But I have written some special code so you can actually, so I actually have RGB colors, but as soon as you fire it up, it does some introspection on the RGB class, creates a BGR class with all the proper hex values for the BGR codes in it, so that you would then use the BGR class to in your actual code, and it makes a big difference.
Sounds like basically you could override the function that when any of the parameters is the RGB value.
Yeah, it's not that easy.
All right.
Do that. It was better to actually. So what I do is I have an RGB class that generates that I have all the values for. I don't know. It's about 20 different colors, and the BGR class, when it runs, it actually pulls in the RGB class and does the correct shifting on each of the colors in a for loop. Actually, it's in a list comprehension, a Python list comprehension, and because they're a lot faster, and generates the classes. So as soon as you boot up, as soon as you turn everything on and you bring up your app, it's there. It's done. It's only done once in the boot up time. So it seems to be pretty quick. I still have to go in and do some optimizations and whatnot. If I get it working good enough, I may bring it along to the ROSFest. I'm not sure if I'll be able to.
You know, there's no reason why you can't bring works in progress and unfinished projects to the Hamfest, because basically we want to show off to people making things.
Yeah.
You know, and the process of development.
This is all code, so my hardware is not exactly in. It's like in pieces with. Here I can. Take these pins off.
We'll try to make sure we have enough screens for you to show things off on.
Yeah, so I mean that's it with my hand over the screen. So yeah, so that's basically it. That's the RPI. That's a version 3. I just happen to have an extra version 3 kicking around. That's the board. And this kind of works. The other LEDs and resistors on here actually have nothing to do with this, but yeah, it seems to be doing fine. It seems to be working great. Took me a while to figure out. I was actually using the GPIO library to set all the pins, and that was screwing it up for the SPI dev library. As soon as I stopped presetting those pins, the dev library worked fine. And it took me, it had to been a week and a half to figure that out. I was pulling my hair. Why isn't this damn thing working? It should be working.
Undocumented software feature.
Yeah, well, The documentation on the standard SPI dev library is terrible, absolutely horrendous. And it's the one that generally gets installed by default on a Raspberry Pi. So it's not a, and it's very hard to figure out what's going on in there. I actually found somebody else had written some documentation on it, and he's even guessing, and he tells you where he's guessing. But there's a lot of stuff. I also found that the function that they say to use to do writing with is about half as fast as another function, which is even less documented. The one that's less documented is like twice as fast.
Sounds like you need to contribute to the project and give them some better documentation.
Yeah, well, well, maybe. It's written in, have you ever seen C code that has Python wrappers in it specifically so that you can use it within Python? That stuff is a nightmare to figure out.
Yeah.
It is not simple stuff. And I actually got an intro on how to do that. There's entire books written on how to do that stuff. So I haven't had the time to go into it. The other thing I wanted to mention is I had mentioned that there is a special board for a computer with 40 pins on it that work just like a Raspberry Pi. So I was going to do all the testing on that. And I found that they didn't even have SPI implemented at all, which means I'd have to write all of the SPI stuff to get that to work. And I'm figuring, okay, that's outside the parameters of what I want to do here. So who knows, maybe someday I'll do that, but it looks like that part of the project is not going to happen. After I get all the tests done for the Raspberry Pi, I'm going to start working on the MicroPython and the CircuitPython. And CircuitPython, I'm already running problems with. They do not do introspection properly. They do not do standard introspection in Python, where MicroPython does. Now figure that out, because supposedly it's a copy of MicroPython, but they've really screwed up how Python works. So it's very hard to get anything where you're doing introspection to work right. Do you know what you guys know what introspection is? So introspection in software engineering, I first learned how to do this when I did a lot of Java work. Introspection is you have special code that looks down into the bowels of the language and figures out how things operate. Okay. And you can do really interesting things like, so this is actually how I'm generating the BGR code out of the RGB code, the hexadecimal values. So it goes into the bowels of Python and pulls out a bunch of stuff. It just makes things tons faster than trying to do it in actually straight Python. Some things you can't even do in straight Python. You got to use introspection to do it. But so, I mean, for example, there's a place here where you have to pass in a class, but I need the class name as text. How do you do that? So there is a prescribed way to do it, and there is CPython's way of doing it, which is not the same. It works on everything. It even works on MicroPython fine. CircuitPython, it doesn't. So I had to find a different way to do it on CircuitPython. So, but you have to use introspection in either case to do it. So you got to know what to look for in the bowels of Python, and to have the names stored in there, and you can actually pull out the text name for the class. That way a person can pass in another RGB class, as long as it's set up the same, but has maybe a lot more colors in it or something. And I'll still be able to pull out the class name when they do it. So that's the reason for doing that kind of thing. But What I did find is Python, MicroPython, which is supposedly based on Python, the CPython 3.5, actually went back and implemented what's called F strings, which is only in 3.6 and above, which I thought was kind of cool because they make doing strings really fast. The problem is that CircuitPython doesn't do it, so I can't use it. But I thought it was kind of interesting. I go, wow, that's working. It shouldn't be working because I forgot to fix my code, knowing that it probably wasn't going to work. I forgot to put in the dot format statements, and I had an F string, and it actually worked on MicroPython. So I go, huh, that's interesting. Anyway,
I heard that CircuitPython deprecates interrupt handling. Users messing with interrupts. Is that the case?
they don't even have interrupts. They can't even handle interrupts in CircuitPython at all.
Well, that's pretty strong deprecation.
Yeah. Well, so their argument, okay, is that, well, we made this for beginners. And I go, okay, that's fine. So all the beginners learn it on Adafruit boards. Now, what all beginners, unless they completely stop, become intermediate. And after intermediate, you may become a professional. Who knows? As you get older, intermediate or beginner may start at 8 or 9 years old. What happens when you all of a sudden read about interrupts and you find out, oh, CircuitPython can't do it? That means I got to find a different board that's not made by Adafruit and put MicroPython on it, which does do interrupts. What happens is Adafruit loses customers. This is just a stupid thing. They need to fix it for their own sake.
It's not the market that they're after.
But
it's not the market.
Right, Pete.
It's not the market they're after, though.
Well,
it's like Mercedes. Mercedes doesn't build cheapo land movers, right? They're not after that market.
Well, those land
they're happy with their 2%.
Go ask Caterpillar. Those things are pricey. Yeah, I know what you're saying, but wouldn't you like to? I mean, they make some advanced boards. They don't just make beginner stuff, but none of their even more advanced boards work with MicroPython anymore.
Yeah, that's a shame.
Duh. Anyway, right. I took up enough time. I'll put a link in maybe when I do the video. I'll put a link in to the. So my code is now up on GitHub. So if you want, I can put the link in here too, so you guys can have it. But I'll stick it into. Let's see.
Very good.
So last month's problem of the month was my physical therapy monitor. And I thought I'd report on what I did. So I'm going to plug in a different camera. So this is my device. This is a strain gauge, aluminum bar with a couple of holes twisted into it. It's mounted to a piece of angle iron. And at the end here, I have welded on, let's see if I can find this here. Yeah. In my welding class, a small extension here with a hole in it. And there's one at the bottom. And this fits on the hinges of my closet door so that I can do my exercises. And so the This end of the strain gauge is bolted with a couple of washers. This end of the strain gauge is cantilevered out into the air. And there is a small length of stainless steel aircraft wire, braided wire rope sometimes called, with a little stop here that I machined with a screw in there to hold this end. And then on the other end, I have an eyelet that gets swaged on and a little like carabiner clip, which hooks onto the elastic band. And then the other end of the wires coming off of the load cell go into this little board, which is a 24-bit A to D. It's a HX711. And so the load cell has 4 wires that are part of a Wheatstone bridge. And the A to D measures the voltage across there. I've got a little piezo speaker here. This is all on a D1 Mini Pro that has a lithium battery, and I've got a little switch in that battery wire so I can turn it off and on. And so I power it up when I start my exercises. I'm going to unplug this and we'll see if it goes back to my Nikon or not. Yes, good. And let me share my screen. And so the D1 Mini talks to my MQTT broker using Wi-Fi. And then I have a process running on my Linux box that subscribes to that channel. And these are the voltages coming off of that A to D for 10 reps of one of my exercises that I did this morning. And it stores it in InfluxDB database. And I'm using Grafana to do a query into the database, pull out the data, and graph it. I can zoom out. At some point, I should start picking up some exercises I did on a different day. Let me just go back to the last 7 days or something. Doesn't look like I've been doing my exercises much, but I have. It was software bugs. We're not recording it into the database. 30 days. See, you see these little dots. If we zoom in on one of them, it still looks like a little dot. It is one little dot, one little stretch. Let's try a different one. So this is 3 different exercises repeated 3 different times with different resistance bands. The green color band, the red color band, the blue color band. One, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 reps on that one. So I'm collecting data. I could show it to my physical therapist if I wanted to. I've thought about, looking for slopes and having, biofeedback for how quickly or how slowly I'm releasing my arms. But at the moment, all I'm doing is just collecting data. I did have one other note. Where are my notes? So my niece sent me an email a day or so ago saying, I'm still trying to get my Christmas present open. Can you give me Can you give me any hints? I was a little bit sad to hear that.
How many people did you give it to? You have two nieces, right?
I have two nieces, and I also gave them to my brothers. So that's 4. And then I made 2 for a friend's kids, 5, 6. So I made 6. And as far as I know, 5 of them have been opened. But I haven't heard back from either of my nieces, except for from the one.
Maybe this is the first year you really got them stumped.
Maybe I thought this one was going to be so much easier than last year's, but I guess not. So I gave her a couple of hints. We'll see if that. She said she had other people look at it. I don't know what was so difficult about hers. Maybe hers is busted and it's not openable.
Are any of your brothers fathers to your niece?
Yes.
So maybe he can help her if he gets his working.
Right. Well, I'm sure she could ask her sister. I'm surprised that she didn't do that, or maybe she did, and her sister said, "Ask Uncle Paul." I'm not going to tell you how to open it. So. All right. Anybody else have anything before we close up?
Pete, you mentioned that you were having a problem reading the data out of one of these guys, right?
I was having
This is a bigger one than the one I showed before.
I was moaning about the fact that there's no access to the video RAM, and it's not it's a feature. There is no data path for this particular board that allows you to read the video RAM.
Oh, okay. Because on the small boards, there actually is no output for the SPI. It's only one directional, and that would explain it. But this one, the one I just showed you, that actually has both sides. So you should theoretically be able to do something.
Yeah, except that studying the schematic, it's using an ILI 9341 controller, and they just didn't make any provision for it, which is a shame, because what it means is that you have to keep your own frame buffer
in memory.
If you want to, in memory, and try to do that on an Arduino.
Yeah.
Forget it. End of story. It's 80 kilobytes.
Yeah, I've rewritten some of those libraries to eliminate that and not allow you to read back your frame buffer from the shadow copy, so that it would fit on a ATtiny or something.
Wow. Yeah. But anyway, Yeah, I appreciate it, Carl, but unfortunately, I'm beyond hope.
Well, I haven't gotten to doing that chip yet, the 9341. I'm doing the other one first, but that will eventually come.
I can't. Yeah, and I can't remember if it's the limit. I don't. I don't think it's a limitation in the chip. I think it's the circuitry
On
surrounding
the
the chip.
board itself that the chip's
Yeah.
on. Yeah.
Yeah.
Yeah. Well, so I mean, that's the case on these smaller ones, right? Because the smaller one actually does, the chip does have a serial out. They just never bring it out on the board.
Huh.
So, and I have not seen any boards. I've had two boards with that specific one. That's a, let's see, that's a 9225.
Hmm.
So it's a smaller one, smaller screen. But yeah, there's, you can't read anything from the board. So essentially, it's a 3-wire connection.
Carl, do any of these have touch screen in front of them?
Yeah, so this one here, the one I just held up, this one here has touchscreen. So you get this thing with it. Now, there's two versions of this, one with touch and one without. So I got the one with touch so that I could actually code that in. The other board I have, the smaller one, doesn't have touch at all. You can't even get it if you want.
Okay. All right. Well, we'll call it a night.